Hey everyone, I have a box and it's from China and I think it's the BMS's. So let's open this up and see. Alright, it looks like it is the BMS's. We got some bubble wrap here, all of our balance leads. Hopefully these are long enough to do what I want to do with them, but we'll have to see. What is this? Alright, we'll have to dig into this and see what these are for. Well, these are small. That can't be it. Well, these are the screens. The LCD screens. Nice. Here we go. So 12 gauge wire, we have 4 of them. They already have terminal lugs on here, so that's kind of nice. So I don't have to deal with cutting off the little spade connectors that used to come on these. So 16S, 320 amp. Cool. I've never hooked these up before. A lot of people have. So it says factory default setting is 16S lithium ion for different cell number and battery type set by a smartphone. So these are Bluetooth. So let's get started on this. I've never done this before, so I'm starting from square one, total noob. So let's see if we can figure this thing out. These are supposed to be rated for 320 amps, 4 12 gauge wires, no. But for this application, 4 12 gauge wires is completely sufficient, so that's a good thing. We don't have to mess with adding more of these or anything like that. So we can use this as is. These are Bluetooth. I got 6 sets of all of this. Looks like these are all the balance leads and possibly temperature sensors. The BMS itself, I ordered the LCD screens just because I figured quick reference would be nice. And over here I'm guessing this is the wiring for the LCD screen. It looks like this is the wiring diagram for a 14S when you're using a 16S BMS. So we're going to wire up our balance leads according to this. So because we are using 2 batteries in series and because they have 2 separate connections for the balance leads and because of the way they tell us to wire this up for a 14S, this lead is going to go to this battery and this lead is going to go to this battery. So if you ever have to move things around, if you're using these yourself, you can pull these off the BMS and they separate out completely, so it's a lot easier to move these around. So as it turns out, these balance leads are very long, so all of the different techniques that I showed in my balance lead wiring video do not need to be used, because we're going to be able to just solder these wires directly to all of our terminals. All right, so I got this top cover off. This is going to be cells 1 through 7. This will be cells 8 through 14. And you can see all these little wires here for our original balance lead wires for our BMS. And what I'm going to do is just solder all of our balance lead wires right to these. So let's get started with that. All right, so now that we have all these pre-tinned, we can start attaching our balance lead wires. Okay, so for number 7, our diagram says to use the 3rd wire from the end, right here, skip this wire, and then use the wire on the very end here. We're going to have 7, this one's going to be open, and then this one's also going to be 7. I went through and checked all of my wiring with my multimeter, and this one's good, so I'm going to tuck these wires in and then put the cover back on this so I don't short it out by accident. Now we have our 8 to 14 cell battery opened up, and for this one, this is going to be cell number 8, 9, 10, 11, 12, 13, and then 14 is going to be both of these wires. So the very end white wire and the red wire will both go to cell number 14. So let's get started on that. Alright, so now we got our second battery all wired up. We can tuck all this away and put our cat back on. And we should be ready to plug these into the BMS. So now I'm going through and wiring up all my balance leads. You can see this is the main negative here, this black wire, and there are these little plastic pins that I'm able to route this wiring through, and there's also these little T-fittings here that you can tuck the wires underneath to keep everything neat and tidy. On some of these batteries, I was not able to use the T connector down here to be able to tuck these wires underneath. So for all of them that have this BMS cover on here, I just used some 3M VHB double-sided tape. It's very sticky, so once I put this cover on, it's gonna push across these as well and hold this in place. So I don't think I'll have any issues with these wires moving around and rubbing against any of these welds on here, because these are pretty rough. Alright, I have all of the balance leads wired up for all of the batteries. So now we're ready to start getting our settings put into these. I have these wired in series already. This isn't how they're going to sit on the rack, but this is our main negative, and then it flows up here, and then this is the negative on this side, and this is the main positive for the two in series. This is for the main positive. You can see the red wire here, and then this is going to be for the main negative. You can see that black wire here, and these connectors are actually different sizes, so you can't mix those up, so that's cool. We're going to start by, and it's got instructions right here on the BMS. So we're going to connect the blue wire to the battery first, and then we're going to connect our balance leads. And then we have to turn it on. You connect the wires up here. There's a connector for it. And you touch the red and black wires to the positive and negative of a lithium-ion battery, and it'll turn this on. Alright, so now I have all my wires hooked up, and I have this connector in here, and I'm going to take this red and black wire here, and I'm going to touch it to the negative and positive of a flashlight battery. We should start seeing some LEDs flash down here when I do this. Alright, there it goes. It just beeped, so now it's flashing, and this will automatically go into a search mode where the Bluetooth it becomes available to your phone. So I'm going to open up the settings on my phone, pair with a device, and hit search. So here you can see we have the BMS showing up, so we can click on that, and it'll ask you for a pin. And I tried 1, 2, 3, 4, and that worked. So now we can open up the app, and I had to contact the seller to get this app, and I'll leave a link that they sent me for the app and all the instructions and everything like that. So we open this up, and it'll auto connect, and it's connected now. So if you come over here to parameter 2, it'll start showing you some of the readings and everything that this BMS is picking up, but it's not correct for what we want. Right now it's set up for a 16S lithium ion, and we need to set it up for a 14S lithium iron phosphate. So I'll show you how to do that. To change all of this, you go to parameter 1 down here, and it'll bring up all of your parameters for the BMS. So like the cell high voltage alarm, low voltage alarm, high voltage protection, low voltage protection. And you can see right now that's all set up for 3.7 volt nominal lithium NMC. So we need to go through and set this all up for lithium iron phosphate. One thing to note, I'm going through right now and adjusting all of my settings. So you just type in what you want, and then you hit set, and then you hit yes. And you'll hear the BMS beep indicating that it took the setting. Alright, I got all my settings put in here, so I'll scroll through this slowly and kind of show you guys what I put on here. I don't know if these are necessarily the right or best settings, but they've been working so far. It kicks the balancing in, and I think as we cycle these, I'll get a better feel for the way this BMS works. It gives you percentages based on cell voltage, and then it actually has a coulomb meter in there that will measure the amperage coming out and going back in, and it'll give you a more accurate capacity reading rather than just using voltage, which is especially useful for these because they have an extremely flat discharge curve. So that's all of it. So now I just need to do that 4 more times. I went through and hooked up the screen, so there's a main positive and negative here, and these are just wired to my main positive and negative on the batteries, so I think these will take pretty wide voltage range. So it's at 47 volts right now and it's not having an issue with it. And then over here we have a 4-pin connector. There is red, black, yellow, and green. And then down here is a red, black, yellow, and green connector. And these get wired together for the screen. But they wire the red wires together, the yellow wires together, and then the black and green wires get wired to each other. So the green wire coming out of this goes to the black wire to this, and then the black wire to this goes to the green wire to this. So kind of weird, but seems to be working just fine. And then there's 2 buttons over here on the left hand side. So you've got your main screen right here. It tells you your voltage and your battery percentage and stuff like that. But if you hit the lower button, it'll scroll down and show you all of your individual cell voltages. We have all of our BMSs set up for the parameters that we want to use for these batteries. And so now we're ready to tear all of this apart and put all of the rear batteries that are going to go on the shelf onto the shelf, and which will end up being the main positive. I also figured out that these battery screens have more views than what I showed earlier in the video. There's this main screen here, and when you scroll down, it'll give you all of your individual battery voltages up to 32 cells, even though this will only go to 16. It's probably a generic software. And then if you hit down again, it'll go to this screen, which is probably the one we're going to use because it gives us the most information for our application. It's not so cluttered. And then if you keep going, it'll start giving you whether your discharge MOSFETs are on, your charge MOSFETs, whether it's balancing, the number of cells, and temperatures. All right, so before we go any further, I had a bit of a hiccup. So I overlooked something about these fuses. These are A&L fuses. So these are actually rated to 32 volts, not 48 like I originally thought. But the bigger problem is this fuse design is not rated for high current interruption, whereas a Class T fuse like this is. So what can happen is if you have a short circuit on one of these batteries, this will actually arc across here. Even if this metal in here melts away and tries to interrupt that current flow, it can arc, and you actually have an arc plasma across this, and current will continue to flow across that arc. You've probably seen welding before, and that's the exact principle that works on. There's a welding arc, and current's flowing across that arc, and it's melting steel within seconds. So if this were to arc out, everything in its path is going to catch on fire, and that's bad. So I bought these. These are bus current limiting Class T fuses. This particular one is rated to 300 volts AC and 160 volts DC, and the interruption rating is 20,000 amps. So if we have a dead short on these batteries, there's going to be a ton of current flowing through these, thousands of amps, I'm sure. And these are rated to interrupt that current, so I won't have to worry about any kind of arcing. Typically these have like a silica in here that will quench the arc if there is one established across here. So it's really important to use the correct type of fuses for this application, because even though lithium iron phosphate is a safer battery chemistry, you can still run into issues with the wiring or the fuses that you decide to use. Alright, so now we have all the Class T fuses installed. It didn't really take that long, and the safety factor of this is well worth it, because honestly guys, if you're gonna do this, these are probably the one thing you do not want to skimp on. And you can see we bought high quality fuses to begin with, but they weren't correct for this application. So you really need to factor in 3 major things when you're determining what size and type of fuse to use. It's going to be the voltage that you're going to be operating at. It's going to be the interruption current, which these are 100 amp fuses. So the interruption current minimum, and then the maximum current that these fuses may see. Alright, so I kind of jumped ahead on you guys, mostly because we don't have a whole lot of space in here to move around, and bringing all these batteries in and trying to record it was going to be really difficult. So I'm on the 4th battery string now. We have the first 3 in. We hooked up our BMS balance leads. We hooked up our power wire for the screens, and we have our screen data line hooked up right now. So I hooked up the main positive already. I'm waiting to hook up all the main negatives on the BMS side of things to these. Until we're done, we have everything where we want it. All right, we have all of the BMS screens hooked up, and we have all of our battery negatives connected to the BMSs. So we are now ready to take all of our negative leads that run into the bus bar and hook those up, and then turn on the inverter and give it a test run. All right, guys, so I just wired it all up in parallel, and these screens, it's pretty cool. I'm really happy I put 5 on here. So this one, you can see there's about 70 watts moving into it, and then if you go down the line, this one was a little bit higher on the voltage. There's 84 watts coming out, 14 watts coming out, 37 watts coming out, and 65 watts going in. It's kind of cool to see it all moving on each individual screen though. Okay, so we let these balance overnight. They're all reading 46.7 volts, and we bought some conduit. This was already pre-wired. It had 12.3 in it already, so there's a hot, neutral, and ground in here, and the ground is insulated. It's not bare copper, so that's kind of nice. We bought some 3/8 clamps, and we basically just wired it from the outlet. It comes up, and we just routed it through to the input side of the inverter. So now we should be able to operate this in an AC priority mode, where when you turn the inverter on, the output is through the outlet and it'll charge the batteries. So I currently have the charger set to about 75% capacity, so let's flip the switch on it and see what happens. Alright, here we go. Alright, so we've got shore power online, battery charger active, and charger on fast charge. The cooling fan just turned on. Down here on the screen, there we go. AC input is normal, 123 volts. Output is 123 volts, 60 hertz, and the load is in bypass mode. That means that the output on this right now comes in through the outlet, comes up, and bypasses from the input side straight to the output side over here on the inverter. So let's see what we're charging at right now. So 116 watts, 112, 112, 116, 112-ish, and 112. So looks like we're charging at about 2.5 amps on all of these right now. I might try cranking it up to 100% just because I gotta do it. Alright, so I adjusted the charge current control knob here to 100%. So let's see what happens. Okay, everything's on. So cooling fan kicked on, and these are charging 4.7 amps, so 200 watts in each one of these right now. 225. So that's about 1250 watts going into this thing. That's not bad. So we just found our weak link, and it is the circuit that this outlet is on. So it's a 15 amp circuit, and with this at 100% charge rate, the dehumidifier kicked on, and the surge load kicked the circuit breaker off, so we ended up popping the circuit breaker for this. So I reduced it back down to about 50% charge rate, which is fine for right now, just as general charging. In an emergency, if this were being charged off of a generator or something like that, this would be turned to 100% and that dehumidifier would be unplugged, so we wouldn't be using that. Alright guys, so I have a little bit of tidying up to do for the wiring and things like that. I gotta put the cover back on the AC input and output over here on the side of the inverter. But other than that, I think this project's pretty much done. It's up and running, it's charging the batteries right now. The only thing left to do is just general monitoring. I want to start doing some cycle tests and seeing how these BMSs kick off, because these BMSs are going to kick off before the charger on this does, because these are a 7S and this is expecting it to be an 8S, which is the typical number of cells in series for a 24 volt system. So all of the BMSs are going to shut off, and I kind of want to see how this would react. I'm guessing it's just going to shut off, but I don't know for sure, so we need to do that. We need to check the amp hour capacity on all of our BMSs, because I put in 54-ish amp hours because these are slightly degraded. So we're going to fully charge these and do a full discharge cycle and see how that goes. But I plan to upload some videos in the future about just general testing and things like that on this system. But for the most part, we're done. I think kind of sad, actually. I had a lot of fun building this. It was a lot of learning, a lot of learning, and a lot of fun, actually. I invested a decent amount of time into this project. I knew it wasn't a small build because of just what it is. You know, if we had some very large 24-volt batteries, we would not have needed 5 separate strings, 5 separate BMSs, or anything like that. But just to make sure that this thing was safe, I wanted individual BMSs, I wanted individual fuses on the batteries, and you know, we really didn't skimp on anything that I can see. Alright everyone, that's it for this video. Keep an eye out for some testing videos in the future. For now, I'm going to call it quits, and I'll see you on the next one.